All right, as we begin chapter 4, we talk about triangles, which are one of the most common shapes we see in geometry. We're going to apply the triangle sum properties. So how do you classify triangles? A triangle is a polygon with three sides. Okay, the interior angles are on the inside of the triangle. Okay, and there are three of them. So if we have a triangle, those three angles are called the interior angles. The exterior angles are when the sides of a polygon are extended, the angles that form the linear pairs with the interior angles. So for example, if we're going to draw an exterior angle, triangle would be like when you extend the side, that angle where the star is would be an exterior angle. All right, and then the corollary to a theorem is just a statement that can be proven easily by using the theorem. Okay, not really a definition you have to memorize, but we talk about what the corollary is because that comes up in this section. So we got triangle, we got interior angles, we got exterior angles. So classifying a triangle, we have a scalene triangle, an isosceles triangle, and an equilateral triangle. A scalene triangle, zoom in a little bit, has zero congruent sides. So it'll look like this. And it might be something like, could we mark like this? So you know none of the sides are congruent, or we could put like numbers like 4, 8, 10. You could put numbers, you could put dashes. All you know is that there's no sides that are equal. Isosceles triangles have two congruent sides. So an isosceles triangle would look like this. And then equilateral will be three congruent sides. Or all the sides are congruent. So look like that, where every side is the same measure. So classifying by sides would be scalene, isosceles, or equilateral. We can also classify a triangle by its angles. So there is an acute triangle, which would be three acute angles. So it might look something like this, where they're all clearly less than 90, so it could be like 80, 60, and 40. They're all less than 90. Okay. A right triangle would be a triangle that has one right angle. So for example, one right angle will be like that triangle. One of the angles is a right angle. It's impossible to draw a triangle that has more than one right angle. So one right angle will make it a right triangle. An obtuse triangle would be a triangle that has one obtuse angle. So it could be like that. A triangle that has one angle that's clearly bigger than 90. In this case, we'll call it 110. But it could be any triangle with one angle bigger than 90. And then equiangular is three congruent angles. So it'll look like that. All three angles are congruent. So that's how we classify triangles, by sides and by angles. Okay, so example 1 says, Classify the triangular shape of the shuffleboard scoring area in the diagram by its sides and measure of angles. Okay, so we look at the picture. All the angles are clearly less than 90. All right. So if they're all less than 90, we would call this acute. Okay, and then if you look at the sides, you can see that these two sides are marked congruent. So there's two congruent sides. That would mean it's isosceles. Hopefully I spelled that word correctly. So it'd be acute isosceles because you classify it by its angles and its sides. The checkpoint says draw an isosceles right triangle and an obtuse scalene triangle. So an isosceles right triangle we need a right angle and two congruent sides. Right? An obtuse scalene triangle would need an obtuse angle. So like let's say it is 120 degrees. And none of the sides are equal. So they all have different number of hash marks on it. So right here is the isosceles right triangle, and over here is the obtuse scalene triangle. And that was just a sketch we did. All right, example 2. We are going to classify the triangle in the coordinate plane. We're going to determine the triangle is a right triangle. We're going to classify it by its sides. So I'm going to quickly run through how you do this, even though we're not going to do it a ton. But if we're given a triangle in a coordinate plane, what we can do is we can find all the sides by doing distance formula. So like ST, the distance would be using the distance formula. So you take the two y values and the x values and you subtract them. So we would do 5 minus 3 squared plus 2 minus negative 1 squared. Okay, this would be 2 squared is 4. So it'd be 4 plus 9. So this would be the square root of 13. So ST is the square root of 13. Then we'd have to find RT. So do 3 minus negative 3 squared plus negative 1 minus 3 squared. We get the square root of 3 minus negative 3 is 6. So 6 squared is 36. And negative 1 minus 3 is negative 4. Squared is 16. So we get the square root of 52 for RT. And again, we're doing distance formula for these. And then lastly, find RS. Distance formula, take the x's. So 5 minus negative 3 and square them. Take the y's, 2 minus 3 and square them. So 5 minus negative 3 is 8. 8 squared is 64. 2 minus 3 is negative 1. 1 squared is 1. So 64 plus 1 is 65. So are any of the sides the same length? The answer is no. So none of the sides are the same length. So this is a scalene triangle. And now we got to determine, is it a right triangle? So we know it's scalene. We got to determine if the triangle is a right triangle. So we have to see, are any of these angles right angles? Well, this angle is clearly not. This angle is clearly not. We got to find out if angle T is a right angle. So first, find the slope of T to S. So slope of, oops, let me just write that out. Slopes of TS is up 1, 2, 3, to the right 2. So it'll be 3 over 2. And then find the slope of RT. So from R to T, we go down 1, 2, 3, 4. To the right, 1, 2, 3, 4, 5, 6. So negative 4 over 6. If we reduce that, negative 4 over 6, divided by 2, we actually get negative 2 over 3. What do you notice about those slopes? The slopes are opposite reciprocals. So opposite reciprocals mean they're perpendicular. Perpendicular would mean that this angle right here is a right angle. So this would be a right scalene triangle. Scalene because none of the sides are equal. A right triangle because one angle is a right angle. Okay, and this is just kind of reviewing that for slopes. Opposite reciprocals mean the lines are perpendicular. Okay, theorem 4.1 says that the sum of the measures of the interior angles of a triangle is 180 degrees. So the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180 degrees. The exterior angle theorem says that the measure of an exterior angle of a triangle is equal to the sum of the measure of the two remote interior angles. So remote interior means non-adjacent. So like angle 1 is equal to the measure of angle A plus the measure of angle B. So you take the two angles that are not next to angle 1. So angle 1 is equal to angle A plus angle B. All right. So example 3 says, use the diagram of the right to find the measure of angle DCB. So first, we got to find the value of X before we can find the value of DCB. So this exterior angle is going to be equal to the two remote interior angles, or the non-adjacent ones. So it's just like the theorem above. 3x minus 9 is equal to 73 plus x. So we're going to solve this. I'm going to get rid of this x on the right side. 2x minus 9 equals 73. Add 9 to get 2x equals 82. And then divide by 2. X equals 41. So now we want to find the measure of angle DCB. So to find the measure of angle DCB, which is 3x minus 9, we would do 3 times 41 minus 9. And 3 times 41 minus 9 is 114 degrees. So the outside angle is equal to the non-adjacent, or the far away, two interior angles. Okay, and then we have a corollary. So the corollary says that the acute angles of a right triangle are complementary. What that means is the acute angles add up to 90. So the measure of angle A plus the measure of angle B is equal to 90 degrees. Okay, and the reason that is because the whole triangle adds up to 180. And if the right angle is 90, when you add up the other two angles, you should get 90. And then we got a few checkpoints. So example 4 says, the front face of the wheelchair ramp shown forms a right triangle. So we have a right angle. The measure of one acute angle in the triangle is 8 times the measure of the other. Find the measure of each acute angle. So what I'm going to do is call this the first angle and the second angle. If we don't know the first angle, let's call it x. Okay? What do you know about the two angles? We know that one is 8 times the other. So if one angle is x and the other angle is 8 times that, that means the second angle is going to be 8 times x. Okay, so what we have is a triangle that looks like this. We have a right angle, we have x, and we have 8x. So if we add them up, it would be 90 plus x plus 8x equals 180. So 90 plus x plus 8x is 90 plus 9x. It's minus 90 to get 9x equals 90 and divide by 9. So x equals 10. That's one of the angles because the first angle was x, so x equals 10. The second angle is going to be 8 times 10. So the second angle is going to be 80 degrees. So the first angle is 10 degrees, the second angle is 80, and then the last one, of course, is 90 because it was a right triangle. Okay, checkpoint 2. Find the measure of angle 1 in the diagram below. So they give us an exterior angle. Remember, the exterior angle is equal to the remote interior angles added together. So our equation is going to be 3x plus 16 is equal to 52 plus 2x. So we're going to solve for x, minus 2x from both sides of the equal sign. And we get x plus 16 equals 52. Minus 16, and we will get x equals 36. So we get x equals 36. So to find the measure of angle 1, this gets kind of tricky now. If x is 36, we have this triangle, right? This is 52 degrees. How big is angle A if we do 2 times 36? 2 times 36 would give us 72. And what do you know about a triangle? The triangle adds up to 180. So if we want to find angle 1, it'd be angle 1 plus 52 plus 72 equals 180. We're going to minus 72 and minus 52 to get the measure of angle 1 is equal to 180 minus 72 minus 52, which would be 56 degrees. Right, and we are actually going to skip the last two problems.